Solutions for perfect problem 2 from Math 251. We're given functions and asked to sketch their derivatives. Okay. And then it says be precise for any linear segments. And then throw comments in there where you want. I probably won't throw a lot of comments in there because I'm talking, I'll have the video solution, so I'll have those serve as my comments. Okay, so when you stare at this first graph, what I want you to notice is we have 3 different linear segments. So on each of these linear segments, the slope is constant. So what I'm saying is the derivative is the exact same from any x value from negative infinity all the way up to 0. And then the derivative is the same for any x value from 0 all the way up to 3 here, and then from 3 up to 5. So what I need to do is figure out what the derivative is in each of those 3 intervals. And the way I do that is the derivative is the slope of the tangent line to the curve. So if I'm over here, the slope of the tangent line to the curve, well, it's a linear segment, so the slope of the tangent line is the exact same as the slope of this line. So what's the slope of this line? Well, let's see. If it goes through negative 3, 0, and 0, 2, that means it goes up 2 when it goes over by 3. So what I'm saying is that the slope is 3/2 everywhere from here to there. Maybe I'll say, well, I'll just leave it at that. 3/2. It's a height of 3/2. The slope at this point right here is undefined because it's got that sharp turn, hence the open circle. And then it changes abruptly. And now we're decreasing, so I got a negative slope. What is the negative slope? Well, again, it's linear, so the height is just going to be equal to the slope of the tangent line at any point is the same as the slope of this line. So let's see, this one looks like it goes down 2 every time it goes over by 2. So the slope is -1. So I'll find -1 here. I guess -1 is right there. And throw an open circle. Have it be constant until I get over to this point. Coincidentally, they go through the same point. It's total coincidence that this goes through this same point. And then at this point, the derivative is undefined, hence the open circle. And then it switches to this thing. What's the slope of this thing? Well, it looks like it goes up by 5, and then it goes over by 2. Right, up by 5. From -1, up 5 gets me to 4. And then over 2. From 3, I got to go over 2 to get to 5. So it goes up by 5 when it goes over by 2. The slope is 5/2. 5/2 is 2.5. 2.5 is right in here. So what I'm saying is I'm going to find a height of 2.5, put an open circle, and then throw an open circle here. Note I got an arrow here and an open circle here because the graph stops here, but it goes on forever in that direction. Thing in red is a graph of the derivative. What about down here? Well, there's kind of 2 different parts we got to look at. There's this segment that's linear, so the slope is constant. Figure out what that slope is, and then it stays the same the whole time. It looks like it goes up 1 every time it goes over by 1. So what I'm saying is, on this entire part, the slope is just 1. So I figure out where the height is 1 right here. Just so happens to be at this same point. Again, that's coincidence. And it goes in this direction. There's no arrows at the end of this, so I guess I don't really care if you put arrows in or not. You know what I'm going to do? I'm going to throw arrows here and here, and then my answer would have arrows on it. But if you interpret this graph as stopping, that's fine too. So the problem with I don't draw these graphs, I Google graph of continuous function, and then, this comes up, and I throw it on the quiz for you. Anyways, the derivative from here on over is this guy. But what about the rest of this stuff? Well, it starts out, if we go from left to right, which is the easiest way to look at these. If you think about the slope of the tangent line to the curve right here, it would be a negative number. Negative what? I don't know. It's hard to estimate, but pretty damn steep. Maybe -4, -5, something like that. So that means the height here has got to be -4, -5, something like that. My graph is going to start somewhere way down here. And then the slope remains negative. It's still pretty steep, but it's getting less and less steep until it gets to this point right here. When it gets to this point, it's got a slope of 0. So what I'm saying is the slope is getting less and less steep, so this is getting higher and higher until I get up to this point right here. And then what happens? Well, now it is going up. The slope was 0 at this point. The slope is positive. At first, it's a small positive number, but it gets bigger and bigger until it gets over to here. What's the slope here? I don't know. You got to estimate it. 2, 3, something like that. Either one's right. I'm going to go ahead and say it gets to about 3. Throw an open circle there and call that good. As far as whether this is straight or curved or how you draw that, it's up to you. We don't know enough at this point to do anything better than that. So I'm going to leave it just like this. Finally, this mess. Okay, I got to draw something. And the thing that I want to draw is going to represent the slope of this guy. First note that at this point right here, the slope of the tangent line is 0. Better go through this point. At this point right here, the slope of the tangent line is 0. Better go through this point. This point right here, the slope of the tangent line is 0. Better go through this point. So what happens? It starts out going up. So at the start, my slope is a positive number. So I'm positive at the start until I get to this point. In other words, I got a positive height over here, and I stay positive until I hit this point. Then when I hit this point, it turns around and starts going down. It's not going down super fast, maybe at a slope of 1 or so. So what I'm saying is my height gets down here to around -1. But throw an open circle because the slope is now undefined. It switches from this negative slope to, it looks to me to have a slope of 0 right here. So we start out at 0 here, and the slope slowly becomes positive. It's getting bigger and bigger positive until we get somewhere in here where it starts getting less and less positive until we get to here. What I'm saying is it starts out at 0, it gets bigger and bigger positive until I get somewhere in here, and then it kind of starts turning around and gets less and less positive until we get to the top here when it's flat. And then past the top, it starts going down. It starts going down pretty steep. What's the slope here? I don't know, -2, -3, something like that. So the steepest it gets is over here. So this is going to go further and further negative until we get way down here into the -3 or so. Leave that like that. Then what happens? It jumps again. Now it jumps. It used to be going down. Now it's immediately going up. At what rate is it going up? It looks like it starts out going up at about a rate of 1 to me. It looks like the slope is right around 1. So I'm going to pick it up right here. And then it keeps going up, but it's getting less and less steep until it gets to this point. So what I'm saying is my height is going to get lower and lower until I get to this point. And then at this point, it starts going down. And it starts going down faster and faster and faster, and it just keeps going down. So what I'm saying is this line is going to get lower and lower and lower and just keep going down. One little thing, it's undefined at this point. That means the slope of the tangent line is undefined. I'll put a little circle in there and have this guy go down there. Arrows, or do you want to stop them? It's up to you. Maybe I'll put a dot here, and then I'll put a circle here. Put a dot here, that puts a circle here. I don't really care about the ends. So that's that. Your pictures, I mean, you could get this totally right and have pictures that look quite a bit different than these. You know, there's a lot of approximation going on in these. Just make sure you hit the key points. That when the slope of the tangent line is 0, the height here is 0. When the slope is positive, the height is positive. When the slope is negative, the height is negative. Hit those things, you're good. So I'll end this here.